Hi, Assalamualaikum. My name is Muhammad Kamarazi bin Muhammad Said. I'm from Mission 2423B. Today, on this video, I would like to share about lipids, the topic that we have learned on the subject Food Science by Dr. Jack Ma. I hope you guys will enjoy for this video. Thank you. Alright, now I would like to talk about composition of lipids. Lipids are organic compounds which are made of carbon, hydrogen, and oxygen. A group of greasy compounds that do not dissolve or mix with water. Can be found in a plant and animal source. At the room temperature, it's divided by two, which is solid fat animal source and lipid or liquid and oil plant sources. The functional properties of lipids in foods is for emulsion, plasticity, aeration, mouthfeel, flavor, heat transfer, and tenderization. Okay, I would like to explain about emulsion. Emulsion is liquids that will not mix together, are immiscible, such as oils and water. When shaken together, they form an unstable emulsion which separates it left standing. A mixture only remains stable if an emulsifier is used. Lecithin in egg yolk is an emulsifier. Egg yolk is used to the preparation of mayonnaise, where it holds oil and vinegar together. It helps the fat in the cake mix with the egg white. Second is plasticity. Plasticity describes how fats change shape under pressure, such as rubbing or spreading. You can easily rub in soft margarine, butter, lard. Oil cannot be easily rubbed in. Plasticity allows fat to coat each flour particle in rubber in products like short crust pastry or shortbread. Aeration. Aeration to differentiate the consistency and texture of a fat by adding air to the mixture is called aeration. Saturated fats are more effective with aeration than that of an unsaturated oil. For example, when creaming butter and sugar, the texture becomes light and fluffy and changes color from yellow to light cream color. Mouthfeel. Mouthfeel is a lubricant in the mouth. It helps to clear particles of food from the teeth, tongue, and gums during chewing. The creamy texture and smoothness of fat contribute to mouthfeel sensation. Alright. The next one is flavor. Flavor. Fat has the unique ability to absorb and preserve flavors. Oil are often infused with herbs and spices for preservation. Fats also contain compounds that lend specific flavors on their own. The way fat coats the tongue and allow flavor to linger can also alter a flavor experience. I would like to explain about heat transfer. Fat provide one of the most efficient modes of heat transfer during cooking. From deep fat frying to sautéing in the skillet or wok, hot oil is able to transfer high level of heat to the surface of food without overheating the interior portions. Using fats and oil to transfer heat also facilitates crust formation. Tenderization. Tenderization is essential in the preparation of pastry, pie crust, biscuit, and so on. The high saturated fats have large shortening power, such as in a flour mixture it separates the flour starch and protein. When heated has given, it was melts into the dough, thus creating air space when delicate texture of the end of product. Okay, production and processing fats are divided by three, which is have a butter, margarine, and shortening. These three types of fats are different function and also different of consistency.
Assalamualaikum. My name is Wan Muhammad Iskandar Izwa bin Wan Muhammad Yusof. I would like to present about the production and processing of fats, which is butter, margarine, and shortenings. For the first one is butter. How butter is made? The cow eat grass and the cow body turn gas into milk. Human or machine makes cow from udder to pail. Milk may be pasteurized in sterile facility. Then human or machines change creamier milk into butter with buttermilk as a side product. And then the butter is produced. Next is butter production. The butter making process, whether by batch or continuous methods, consists of following steps. Preparation of the cream, destabilization and breakdowns of the fat and water emulsion, destabilization and breakdowns of the fats and water emulsions, aggregation and concentration of the fat particles, formation of a stable emulsion, packaging and storage, distribution. For the margarine manufacturing process, the process is begin with the soybeans, corn, cottonseed or canola seeds are being prepared. The oil is extracted by high temperature and pressure. And then the remaining fraction of oils removed with hexane and other solvents. Oils now rancid, steam cleaning to remove all vitamins and antioxidants, but pesticides and solvents remain. Oil mixed with a nickel catalyst. Oils with catalyst subject to hydrogen gas in a high pressure, high temperature reactor. Soap like emulsifier mixed in. Then the oil steam clean again to remove horrible odor. The grey color removed by bleaching. Artificial flavors, synthetic vitamin and natural colors are added. Mixture is packaged in blocks or tube. And the last one, advertising promotes margarine as a health food. Next is shortening manufacturing process. The process is begin when the oil or fats is melted with the temperature of 70 degrees Celsius to the blending with the temperature of 50 degrees Celsius for pre-crystallization, a unit by the temperature of 70 to 28 degrees Celsius. To crystallization, B unit, and then to packing with temperature of 25 to 30 degrees Celsius, then tempering with temperature of 25 to 30 degrees Celsius, and the last one is shipment. Now, how oil is produced? So this is the process of making the oil. So this is the process of making the oil. The oil seeds are being dyed and being with a magnetic separator, and then with a dehuling or distilling, and it will be the process of soy paste and into the machine that called a solvent extractor, and then into water refining, and then to bleaching, filter, and deodorizing. General methods of extraction. First is rendering. The second is pressing with mechanical press. The third, extracting with volatile solvents. For the first one is rendering. The sub-process of rendering is fruits and seeds. This process is used in the preparation of palm oil. The fresh palm fruits are boiled in water and the oil is skimmed from the surface. Such process can be used only with seeds of fruits such as olive and palm that contain large quantities or easily released fatty matter. For the second sub-process is animal fats. Production of animal fat such as tallow, lard, bone fat, and whale oil. It consists of cutting or chopping the fatty issue into small pieces that are boiled in open vats or cooked in steam digesters. The fat gradually liberated from the cells, floats to the surface of the water where it is collected by skimming. For the second process is pressing process. The general sequence of modern operations in pressing oilseeds and nuts is as follows. The first, the seeds are passed over magnetic separators to remove any stray bits of metal. The second, if necessary, the shell of husk are removed. The third, the kernels of milk or meats are converted to coarse meal by grinding them by groove rollers or with special types of hammer mills. For they are pressed in hydraulic or screw press, with or without preliminary heating, depending on the type of oil-bearing materials and the quality of oil desired. For the pressing machines, the yield of oil from the hydraulic press was considerably higher than that from earlier process methods because of the much higher applied pressures. Pressure on the cake varied from approximately 70 to 140 kilograms per square centimeter, which is 1,000 to 2,000 pounds per square inch, and in the closed tight press, in which the oil containing materials was confined in a strong perforated steel cage during the pressing operation. Pressures of approximately 400 kilograms per square centimeters or more were attained. For solvent extraction, the sub-process is use volatile purified hydrocarbon especially the various grades of petroleum benzene, commonly known as petroleum ether, commercial hexane or heptane. In large-scale operations, solvent extraction is a more economical means of recovering oil than its mechanical pressing. For seeds or nuts containing a higher oil content than soybean, it becomes customary to press the material in screw press to remove a large proportion of the oil before extraction. For the extractor, encourage direct application to oil seeds, and the batch extractor gradually gave away to continuous unit which fresh flakes are added continuously and subject to a counterflow of solvent. Solvent percolates to oil seeds flakes contained in perforated basket moving on an endless chain. After the extraction cycle is complete, the basket of extracted flakes are dumped automatically and then refilled with fresh flakes to initiate another cycle.